Okay, so in the previous lecture we were discussing about the Dhauliganga Dam. This dam is built on the Dhauliganga river and it is a source of hydroelectric power in this region. So there were various environmental considerations which were taken into account while the building of this dam. Let us not go into that detail, but what I am trying to show here is that how a dam looks like. What do? We block the course of a river and make a place where some water can be stored, and while doing so a grand structure is built. Okay, these are various engineering structures. So these just for giving you an example of how these engineering structures are, what their names are. There is diversion tunnel, head race tunnel, surge shaft, tail race tunnel, okay, and the edit tunnel, and the dam is a rock fill dam here. So what I'm trying to tell you is that various engineering structures, they are used for the benefit of humankind, and while making these engineering structures we need to know the geological and the environmental conditions simultaneously. Okay, let us see another example of Chirkila Dam. It is in fact now seen as a tourist place where people go to enjoy their holidays sometimes. So here also you can see the reservoir is made, a dam is made which is blocking the course of the river, and then one conduit is given for the river, and there are various pillar kind of structures which are given a definite name in engineering geology. I will go into that detail in the coming classes. So you can see a grand structure is engineering structure is built which is used for public benefit. So this is another example from Pithoragarh region. I hope you all must have been through this, the BZ bridge at Ghat. You can see large pillar like structures. They are given definite names in engineering. We'll go into that. So a bridge, it joins you to both the banks of the river. And how is this structure actually made? That is not the main criteria of our study. We need to study the geological considerations, okay, in engineering geology. So the abutments or the piers where the these engineering structures will be built, the engineering properties of those rocks have to be studied. And it is not that always you get rocks, there are various soil types also. So we need to study the rocks and the soil simultaneously. Okay, so while making various engineering structures, we need to know the geological aspects also. Now what is that we actually need to know? This is what we are going to study in engineering geology. Okay, so you have seen various examples of engineering structures in your vicinity near Pithoragarh. Let us start with engineering geology then. If we go to the definition of engineering geology, then it means the application of geological knowledge, as I already told you, application of geological knowledge in the field of civil engineering only. Okay, you are not going to use it in some software building, right? So it is used in civil engineering for execution of safe, stable and economic. There are three major points which we have to know. We apply the geological knowledge in the field of engineering geology, civil engineering, for execution of any engineering structure to be made safe, stable and economic. Okay, so those engineering structures may be dams, they may be bridges, they may be tunnels, right? So if we try defining engineering geology, then it means application of geological knowledge in the field of civil engineering for execution of safe, stable and economic construction of engineering structures like dams, bridges and tunnels. Okay, so engineering geology is in fact a branch of earth sciences. It links classical geology with engineering and environment. We already discussed it. So we need to know all the geological aspects like mineralogy, structural geology, physical geology of the area in which we are going to work, or of the area in which any building is going to be constructed or any engineering structure is going to be built. So what we are going to do is we need to intermingle geology, engineering and environmental considerations while we are studying engineering geology. Okay. So Fred Bell, 1992, the book which I am trying to say that you need to read this also. So Bell in 1992, he defined geology, engineering geology, as the application of geology to engineering practice. Okay. So in different words also, geological factors which influence the location, design, construction and maintenance of the engineering works. So we are going to highlight the geological factors which will help in understanding which location should be chosen for building an engineering structure, which kind of design should be made depending upon the geological conditions of that area, what kind of construction and maintenance conditions should be taken into account. These are to be discussed in engineering geology. Okay. So what is the primary focus? Engineering geology, it helps ensure that a structure can be built safely, properly and economically. It is given in the definition also. Okay. So the construction can be of various engineering structures. We have already discussed tunnels, bridges, dams, etc. Development of near surface resources. So groundwater, geothermal energy, mineral deposits, all these, when we explore these energy sources, during that time also we go to build engineering structures. In that way also engineering geology is required. So we need it to develop the near surface resources. Okay. And then protection from natural hazards. So we need to make various engineering structures, like rock bolting is done. You must have seen various rock bolts near the NHPC plant in the Dhauli-Ganga area. If not, we will discuss about all this, how landslides and other natural hazards can be mitigated, means how can we protect ourselves from various hazards caused due to engineering constructions. Okay. And then near surface behavior of rocks and soils, their geological disposition and their mechanical and hydraulic properties. So if we say how an engineer looks towards rocks, then to an engineer the rock is a material that can be built on. Okay. On a rock he can build various structure. Built in means within the rock also these engineering structures can be built. Built with, these rocks are used to build the engineering structure and they support also. Okay. So to an engineer the rock material is that can be built on, built in, built with and which supports. And if we talk about the geologist, so for geologist the engineering structure will have various responses in terms of geological conditions. Okay. So if a ground is soft ground, it has settlement, or if it is a weak ground, it has potential failure or various other such features. So various engineering responses must be there. If the ground is soft, the foundation design, it has to be made in such a way that it reduces the load on the structure, on the foundation in which it is built. Okay. Simultaneously there are various geological conditions which give rise to various responses that have to be checked while making a geological structure. This is what we are going to study in the next units. So while studying engineering geology, you need to know what petrology is, because you have to know the composition, texture, strength, durability of the foundation rock on which the engineering structures are going to build. You need to know structural geology. Why? Because if a fault is present or a fold is present or the faults are in such a way that the stress is not being able to distribute equally, that may cause rupture during earthquake or any other such condition, or the rocks are fissile, or various other reasons, like if there is a stress zone or a gap zone, or if there are shear zones. So various factors have to be seen in order to build a foundation, in order to know the foundation of a rock. Okay, so you will always prefer making a foundation on a hard rock. We'll go into the details of what a hard rock is. A granite may be more suitable than a fissile shale, so you need to know the petrology in that way. And then the structures which have less shear zones or less impacts of brittle deformation, they may be useful as foundation rocks. We need to know the dip of the bed while we are making a road, so that the material doesn't just comes in the road while we are building it. So I'll show you all this with the help of various diagrams. These diagrams are in K.S. Valdia's book. So from engineering point of view, structural geology is very important, because geological structures, they can be modified on the basis of the characteristics of the rock in which they are being built. Okay, so we need to know the geological setup of that area. And then what we can say is, geology is overall important in understanding the engineering characters of any area, the geological characters of any area, because they help us to understand the stability of the rock on which the engineering structure is being built. So we need to have pre-planning before making any any engineering structure, for which geology is must. Okay, so geology helps us understanding the various foundation problems and groundwater problems and various other problems. Okay, we are going to discuss all this. So if we talk about engineering properties of a rock, which can be seen as a foundation on which any geological any engineering structure is built. So engineering properties, they are considered broadly as physical, chemical and biological characters that are observable, measurable and also influence behavior of the extent that they are important in engineering analysis and design and in performance of component, system or processes. This is the definition given by Munro in 2018 to understand the engineering properties of a rock on which any foundation is being built. Okay, so these can be divided into engineering properties of rocks and engineering properties of soils. So let us understand engineering properties of rocks. Engineering properties of rocks are controlled by discontinuities which are present within the rock mass. Now what are these discontinuities? In field, you have learned that various discontinuities are named as S0, S1, S2, S3 depending upon the chronology of their formation. Okay, so these discontinuities are the planes which define deposition at different levels, or which defines the amount of stress which has been faced by a rock, that is present in the form of viscosity within the rocks. Okay, so these discontinuities may be planar, they may be linear. They may be planar means a bedding plane may be a planar discontinuity, they may be linear, any dike can be a linear discontinuity, any sill can be a planar discontinuity sometimes. So broadly speaking, the discontinuities can be planar and linear. Okay, and the cleavage plane, the joint planes, the fractures, the fault planes, all these are various discontinuities which are present within a rock mass. More will be the discontinuities, lesser will be the strength of the rock. It is very simple. It is a basic thing which everybody understands, that if a rock is broken means it has various discontinuities in the form of faults, fractures, various viscosities. then it has to be comparatively less in strength. Okay, other than that, there are inherent properties. You know that a rock is permeable if its pores are connected to each other, and sometimes the fractures present in a rock may be also connected to each other, giving permeability, more of permeability and more of transmissivity. Okay, so there are inherent properties of the rocks also, means the composition, the petrology of the rock, that also matters. So the discontinuity is present due to stress that has been faced by the rock, or the inherent properties that are based on the mineralogy of the rock. A granite is completely different than shale. A shale has different composition than of granite. Okay, now when granite deforms, the way it deforms will be completely different from the way a shale deforms. So the rheology also matters here. So those properties which are relevant to engineering application after or before their excavation are seen by us. After excavation means for construction such as building stones, rock, stones, or aggregate for concrete making, and before excavation means qualities of a natural bed where it exists. So how it is when it is in situ and how it behaves when it is not in situ. So a combination of laboratory testing techniques are used to analyze these. So we have laboratory testing also, we have field observations also to understand the engineering properties of any rock. So these properties may be divided into two categories: intact rock properties, which are identified on the basis of laboratory tests, and rock mass properties, which also need visual examination in the field. Okay, so when the rock is intact means what we do is we take a core of the rock sample and then we take that sample to the engineering laboratories where various instruments are used to analyze their specific gravity, point load strength, compressive strength, tensile strength, and various other properties. Whereas being in the field, we can measure the different discontinuities present within a rock. That may be fractures, that may be faults, or there may be joints. So we describe them in a particular width, in a particular sample which has a particular volume, a width, a length, and height. Okay, simultaneously here also we take a core. Here also we can identify various discontinuities present within the core. So when we talk about the strength properties of rocks and rock masses, what are the factors or the parameters that affect rock strength? How do we test a rock for its strength? So what do we do is we make various laboratory tests to understand this, and while doing these laboratory tests we identify the uniaxial compression strength, the point load testing, the uniaxial test, tension, indirect tension test, shear test, confined compression test, biaxial and multi-axial test, and various other tests to understand the strength of a rock in the laboratory. We can also use various criteria like Mohr criteria, Mohr-Coulomb criteria. You have seen the Mohr circle when you study structural geology. So this is where we are going to employ the Mohr circle to understand the failure criteria of any intact rock and the rock masses. Okay, so please feel to ask questions, and in the next lecture we will discuss in detail about what the engineering properties are one by one, and how these are analyzed in the laboratory and how they are analyzed in the field also.